Good afternoon, student. Today we are going to see about what is the second topic, that is relational algebra in a database management system. Okay, in the last class we discussed that is a ER diagram. So the ER diagram is that is an entity relationship. Entity relationship model consists of the collection of the basic object called entities and of the relationship among these entities. Okay. So when you are using this ER diagram, we should use the three components, that is entity, attributes, and then relationship. Okay. So entity is the things or object in a real world. Okay. Entity is the things. Okay. Entity is the things or object in a real world. And then the entity set is the set of the entities of the same type that share the same properties or attributes. Okay. And attributes, what is mean by attributes? I already told you, know. So that is attribute is the entity is represented by a set of the attributes. The entity is the things or object in a real world, and the entity is represented by a set of the attributes. Okay. For example, if you are taking a student table, okay, the student table is a student as the entity. So in that student table having a student name, ID, roll number, age, and then marks. So these are the attributes of there in that student table, right? So this is called as a attribute. That is a column name. Okay. And then the relationship. Okay. What is in the relation? Anyone tell that answer? The relation. It's already taken, you know. Okay, the relationship among these entities. Okay, the relationship as the association among the several entities. Okay, the relationship as a association among the several entities called as a relationship. Okay, so if you are using entity, that is represented by the rectangle, if you are using that as attribute, that is represented by a ellipse. Okay, and if you are using a relationship, that is represented by the diamond symbol. So if you are using a line, okay, which line, that is which link the attributes to entity set, okay, and entity set to the relationship. Okay, if you are using entity, that is represented by the rectangle, if you are using the attribute, that is represented by the ellipse, if you are using a diamond symbol, that is relationship, that is represented by the diamond. If you are using a line, okay, that is which link attribute to the entity set and then entity set to the relationship. Okay, so these are the components are we seen in that last class. Okay, today we are going to see about that is a relational algebra. Okay, so in that relational algebra we have to use some operator. So that is a selection operator, projection operator, union operator, intersection operator, Cartesian product, and join operator. So these are the operators that we have to see in this section. Okay. What is meant by relational algebra? So the relational algebra is a procedural language. Okay. So that is work on the relational model. The purpose of the query language is to retrieve the data from the database or perform the various operations such as the insert, update, delete on the data. Okay. The relational algebra is a procedural language. Okay. So what is my language? That is what is my, that's a procedural language. So when you are using a relational algebra, we can use the query language. What is my query language? So while creating the database, if you want to extract some information regarding the data in the database, so then we can use the query. Okay, the query is while creating the database, if you want to extract some information regarding the data in a database, okay, then we can use the query. Okay, so in a relational algebra, we can use the query language. Okay, the query language is a language in which a user requests information from the database. The query language is a language in which a user requests information from the database. So these languages are usually on the level higher than that of the standard programming language. Okay, these languages are usually on level higher than that of the standard programming language. The query language can be divided into two parts. The one is a procedural language and then second one is a non-procedural language. Okay, I already told you know the relational algebra comes under the procedural language. Why it does? Okay, what is in the procedural language? In the procedural language, the user instructs the system to perform the sequence of the operations on the database to compute the desired result. Okay, when you are using a procedural language, the user instructs the system to perform the sequence of the operations on the database to compute the desired result. Okay, so what is my non-procedural language? Okay, you've seen the procedural language and what is meant by the non-procedural language. In a non-procedural language, the user describes the desired informations without giving the specific procedure for obtaining that information. Okay, when you are using a non-procedural language, the user describes the desired information without giving a specific procedure for the obtaining that information. Okay, so the relational algebra using the query language is a language in which the user requests the information from the database. So these languages are usually on the level higher than that of the standard programming language. Okay, the query language can be divided into two parts. One is a procedural language and then non-procedural language. Our relational algebra comes under the procedural language, which means that the user instructs the system to perform the sequence of the operations on the database to compute the desired result. Okay, the purpose of the query language is to retrieve the data from the database or perform the various operations such as insert, update, delete on the data. Okay, here we are going to use some fundamental operations. Okay, that is selection, projection, union, set, different, and then Cartesian product. The last one is a rename. Okay, next again we are going to use the derived operations. That is natural join, left, right, full outer join, intersection, and then division operations. So these are the operations that we have to see in this session. Okay. So what is relational algebra? It's a procedural language, which means that let us the user instruct the system to perform the sequence of the operations on the database to compute the desired result. Okay, it consists of the set of the operations. So that take one or two relation as an input and produce the new relation as the output. Okay, it consists of set of the operation that take a one or two relations as an input and produce a new relation as a output. Okay, these operations enable the user to specify the basic retrieval request. Okay, and the fundamental operations in a relational algebra are select, project, union, set, difference, Cartesian product, and then rename. Okay, these are the fundamental operations are used in a relational algebra. That is select, project, union, set, difference, Cartesian product, and then rename. The first three operations, that is a select, project, and then rename operations are called as a unary operations because they operate on the one relations. The unary is indicating the one relations. Okay, so select, project, rename operations are called as a unary operations because they operate on one relations. The other three operations, that is union, set, different, and then Cartesian product. So these are the binary operations, which means that they can operate on the two relations. Okay, if you are using a unary, that is indicating the one relations. If you are using a binary, that is indicating the two relations. Okay, please keep it in mind. Binary means that is a two relation. Unary means that is a one relations. The unary is that is a select, project, and renames. These are the operations are unary operations. And then the union, set, difference, Cartesian products. These are the binary operations. Okay. So First, let's see about the unary operations. That is a selection. Okay, that's indicating by the sigma operator. Okay. First, let us see about the selection operation. The selection means select the subset of the row from the relations. Okay. Select indicating via sigma symbol. So this is a sigma. Select the subset of the row from the relations, and then projection. So that is indicated by a pi symbol. Okay, this is a pi symbol. So which means that select the column from the relations. Okay. Next, let us say about the rename. The rename is indicated by the row symbol. Okay. The rename the table. Okay. So next, let us see the selection. Selection syntax. So, okay, when you are writing the selection, okay, first we put the sigma, that is indicating by the selection. Okay, first we can put, that is a sigma operator, and we can call the predicate. Okay, then put the relations where the sigma represent the selection operations, and then the predicate. So this is a predications. The predicate denote some logic using which the data from the relation is selected. Okay, so the predicate denotes some logic, okay, using which the data from the relation is selected. Okay, suppose we consider the student table. Okay, in that student table having a student ID as name and then age and then gender. Okay, but for us fetch the student with the age more than the 80. Okay, for that we can write the relational algebra. Okay, how you write? First we can call the sigma operator because that is indicating the selection. Okay, first we can put the sigma. After that, our queries fetch the student with the age. Okay, fetch the student with age the more than 18. Okay, so the condition is first we can put the sigma and then the age greater than 18 of the student. The student is a table name. Okay, so this is how it will be written. Okay, so the syntax is sigma and then selection criteria and then input. Input is a table name and then selection criteria is a predicate, that is denote some logic using which the data from the relations. Okay, the selection operator specify the tuples to return through the selection criteria. So the selection criteria is the Boolean combinations, that is using the union and then intersection of the terms. The terms means that is attribute or operand. So when you are putting the attribute, so okay, first we can put the attribute and then we can call the operator and then again we can put the attribute. Okay, so the operator will come between the two attributes, that is attribute 1 and then operator and then attribute 2. So this operator can be less than or equal to, less than or equal to, less than and equal to, greater than or equal to, or and then greater than. Okay, so in this way it can be declared. When you are using a selection, first we can call the sigma operator. Okay, after we can call the predicate, that is a selection criteria. Okay, next we can put the relation, that is a table name. Okay, here we are going to take a student table. Okay, in that student table having a student ID as name, age and then gender. Okay, for this student table we can find the query. So what is that? The fetch the student with the age more than the 18. For this we can write the we can write it in a relational algebra as the sigma, the age greater than 18 from the student table. So in this way it can be declared. Okay, let us see the example of this selection. Okay, one more example. Suppose we are taking the student. Okay, in that student table having a student ID as name, age and then gender. Okay, the whereas fetch the student with the age the more than the 18. Okay, for this we can write it in a relational algebra as the sigma, the age the greater than 18 from the student. Okay, so in this way it can be declared. Okay, the one more table, that is a employee table. So in the table having a employee name, employee number, department number, and then salary. So these are the attributes of there in that employee table. Okay, this is the assumption. Okay, for this we can write the query. Okay, the query select the employee tuples whose department number is 4. Okay, our query is select the employee tuples whose department number is 4. Okay, so that we can write it in a relational algebra as, first we can call the sigma operator because that is indicating by the selection. Okay, when you are using a selection, first we can call the sigma. Okay, after that we can call the predicate, that is a selection criteria. The criteria is whose department number is 4. Okay, so that the department number is equal to 4 from the relation, that is the employee is our table name. Okay, in this way it can be declared. So one more query. Okay, that is select the employee tuples whose salary is greater than the 30,000. Okay, for this we can write it in the relational algebra as, first we can call the sigma and then our predicate as salary, right? Okay, that is a selection criteria as salary is greater than 30,000. Okay, so the salary greater than 30,000 from the employee. Employee is our relation. Okay, and one more example, that is select the instructor in the physics with the salary greater than 90,000. Here we can use the two conditions. Okay, select the instructor in the physics with a salary greater than 90,000. Okay, here we can use the two statement. Okay, first we are going to select the instructor in the physics. Okay, with the salary greater than 90,000. First we can call the sigma operator here. Next we can find out the department name because they are asking the instructor, select the instructor in a physics. Okay, so that this physics comes under the department name, so that we can call the department name here. Department name is equal to physics. Okay, then we can call the union and then intersection operator. Okay, that is a not in, this is a and then or. We can find out the two statement. One is the instructor. For that we can write it in a relational algebra. Okay, when you are writing the relational algebra, first we can call the sigma because we are using the selection. Okay, so that we can call the sigma here. Next our condition is select the instructor in the physics, so that we can call the attribute name, that is a field name. The field name is department name is equal to physics, and then we can call the or operator, that is and operator indicating the intersection. Okay, and next we have to find the salary is greater than 90,000. So salary is greater 90,000 from the instructor table. This is the table name. Okay, here the employee is the table name, here the instructor is the another table name. Okay, so the sigma department name is equal to physics, and then using the and operator, and we can find out the second statement, that is with the salary greater than 90,000. Okay, the salary greater than 90,000 from the instructor table. Okay, so that it comes here. Okay, clear now? Shall I move now? Okay, next let's see about the projection. Okay, so what is my projection? Why we are using this? So the projection indicating by a pi symbol. Okay, the projection operation is used to project only the certain set of the attributes of the relation. When you are using a projection operation is used to project only the certain set of the attribute of the relation, which means that if you want to see only the name of all the student in a student table, then you can use the projection operations. Okay, which means that the project only a certain set of the attribute of the relation when you are using a projection. So can be written as pi, the field of the input. Okay, the field is the column name. Now allow us to extract the column from the relation. The relation is a table name. Okay, when you are using a projection, you should to project only a certain set of the attributes of the relation, which means that so you want to see the only the name of all the student in a student table. Suppose we are going to take a student table. In the table, if you want to see only the name of all the student in a student table, then you are taking the student table. In that student table, having a student name, student number, and then marks, age. So these are the columns are there in that student table. So in the table, if you want to see only the name of all the student in a student table, then we can use the projection operations. Okay. Thus, to display the particular column from the relation, the projection operator is used. Okay. It will only the project or show the columns or attributes asked. Okay. Then it will also remove the duplicate data from the columns. Okay. When you are using a projection, that is project only the certain set of the attributes of the relation. Okay. So, and also remove the duplicate data from the columns. Okay, this is the syntax of the projections. Okay, the the field of the input is a table name, the field is a specific field, attributes. Okay. Okay, here we are going to take a student. Okay, so in that student table, having a student ID as name, rating, and then age. Okay, here if you want to see only the age of this student table. Okay, then you can use the projection operations. Okay, and the output will be like this. Okay, because for using, if you want to see only that is the age of this student. Okay, age of the student. Okay, so that the output will be like this. Okay, next let's see about the example of this projection. So that whereas to list the each employee first and last name and then salary, the following is used. Okay, that whereas to list the employee first and the last name and then salary. Okay, here we are going to take the employee table. So in that employee table, having an employee first and last name, salary, and then employee number. So these are the columns are there in that employee table. Okay, so in that table we find out only the employee first and last name and then salary. Okay, so that first we can call the pi operation because we are using a projection. Okay, suppose if we are using a selection, we can call the sigma instead of the pi. Okay, if we are using a projection, we can call only the pi. Okay, that is indicated by the pi symbol when you are using a projection. Okay, so the pi, and then we can call a certain set of the attribute, that is we have to find out the first and last name of the employee and then salary. Okay, so these only we needed. Okay, we have to find the employee first and last name and then employee salary. Okay, so that first we can call the pi operation because we are using a projection, and then the attribute, that is we have to find out only the first and last name of the employee and then salary. So that we can call their first name, last name, first name, salary from the employee table. Okay, so in this way it can be declared. Okay, when you are using a projection, first we can call the projection operator, that is a pi. Next we can call the certain attribute because when you are using a projection, project only the certain set of the attribute of the relation, right? So that we can find out the last name, first name, salary from the employee. So in this way it can be declared. Okay. Okay, next let's see about the rename operations. Okay, the rename is represented by the row symbol. This is the row symbol. Here we are using that as a table name, that is S is a table, that is a relation name only S. Okay, the column. So the column attribute names only to B1, B2 and then Bn. Okay, the relation name to S and then the column name to B1, B1, B2 and then Bn. So in this way it can be declared. When you are using a rename, so the rename operation, that is indicated by symbol, can be expressed by the any one of the following forms. That is the row of S of R. R is a relation. Okay, the relation name only to S because they are using S only here. Okay, next another example is the column. The column, the attribute. This is the attribute, the B1, B2 up to Bn. Okay, the column attributes names only to a B1, B2, and then Bn. Okay. Next, let the relation names to S and the column names to B1, B2, B1, B2 and then Bn. Okay, next let us see about that is a set theory. Okay, in the relational algebra. So already I told you know the various type of the relational algebras are that is selection, projection, Cartesian product, set operation and then join operations. These are the operations are used in that relational algebra. Okay, the relational means that is a selection, projection, Cartesian product, set operation and then join operations. When you are using a set operations, so that has the union, intersection, set different and then Cartesian product. Okay, when you are using a set operation, so that has a union, intersection, set different and then different, Cartesian product. Okay, let's see the union. Okay, so union is one of the binary operation because here we are use the two relation. Binary means the two relations, right? So it is a binary operation denoted by a U. That is, this is a symbol of union. That is a union. Okay, the result of the R union S is a relation that includes all the tuples that are either in R or in S or in both R and S. Okay, the result of R union S. The R is a one table and S is another table is a relation. The R is a one relation and S is a another relation. Is a relation that includes all the tuples that are either in R or in S. Okay, in or in both R and S. So it can remove the duplicate, tuples. Okay. The union, this operation used to fetch the data from two relations. Okay, when you are using a union, okay, when you are using a union operation to fetch the data from two relations. Okay, for this operation to work, the relation specified should have same number of the attributes and same attribute domain, and also duplicate tuples are automatically eliminated from the result. Okay, so when you are using this union operation to fetch the data from a two relation, okay, so that is the relation is R and S. Okay, in the R and S, that is syntax is R union S. Okay, where the R and S are relations. Okay, so if there are two tables, for example, if there are two tables, the student and then book. Okay, in the student table having a student ID, student name and then age. In a book table having a ISBN number, book name and then author. Okay, like whereas we want to display the both student name and then book name from the both table. Okay, then we can write it in a relational algebra. Okay, we can write it in a relational algebra as, so we can, so first we can call the projection operation. Because why we are using projection first? Because we select the certain attribute from the table. So we want to display the student name and then book name from the both tables. So that we can call the projection operator. Okay, projection operator, then the student, the union of, and then the projection, the book. Okay, in this way it can be declared. Okay, when you are using a projection operation, that is for this operation to work, the relation specified should have a same number of the attributes and then same attribute domain, and also duplicate tuples are automatically eliminated from the result. Okay, so this is the example of the set operation. Here we use the two tables, that is a S1 and then S2. Okay, S1 table having a student ID, student name, rating and then age, and then S2 table having student ID, S name, rating and then age. Here we can do the union operation, union operations. Okay, that is S1 union and then S2. Okay, it can be, we can write it in a algebra, relational algebra as. So why we are using this set operation, that is a union. So what is the use of this union? When you are using this union, so the specified should have a same number of the attribute and same attribute domain, right? So that the output will be like this. Okay. So and also the duplicate tuples are automatically eliminated from the result. Okay, when you are using a union. Okay. So this operation used to fetch the data from the two relation. S1 is the one relation and then S2 is the another relation. Next, for this operation to work, the relation specified should have a same number of the attributes. And then attributes means that's a column. And then same attribute domain. And also duplicate tuples are automatically eliminated from the result. Okay. So that the output will be like this. So the S1 and then S2 table, we done a union operation here. So that the output will be like this. Next, let's see about the intersection. Okay, so that is denoted by this symbol. Okay, that is intersection operations. This operation used to fetch the data from the both tables, which is the common in both tables. Okay, here also we are going to take two tables. They named as R and S. Okay, this operation is used to fetch the data from the both tables, which is common in the both tables. Okay, so both are. The operation is used to fetch the data from the both tables, which is common in the both tables. Okay, the syntax is that is R union intersection. Yes, that is R intersection S, where the R and S is the R and S are relations. Okay, so consider the example. Okay, so the consider two tables, the student and then worker. Okay, in that student table having a student name and then branch. Okay, and then the worker table having a worker name and then salary. Okay, whereas if you want to find out the name of the student who are working in a company. Okay, whereas if you want to find out the name of the student who are working in a company. So first we can find out the name of the student, so that we can call the projection here. Okay, because you have to find out a certain attribute, that is the name of the student. Okay, so pi of the name. First we can put the pi and then name from the student and using a intersection operation here. Then again we can use the pi operation and the name from the worker. Okay, because this operation is used to fetch the data from the both the table, which is common in the both tables. Okay. Okay. So here is the example. The S1 is the one relation and then S2 is the another relation. Next we can do the intersection operations between them. Okay, that is the S1 intersection and then S2. This operation is used to fetch the data from the both table, which is common in the both tables. Okay. So the S1 table having a 3 rows and then S2 table having a 4 rows. Okay. So fetch the data from the both tables, which is common in both tables. So the 31 to 58 is a common in both tables. So the output will be like this. Okay. This is another example. So in the table having a student ID, section ID, semester, year, building and then room number, time slot. Okay, based on this table we can see some example. Okay, that whereas consider the query to find the set of all the courses taught in the fall 2009 semester and the spring 2010 semester are both. That whereas they consider the query to find the set of all the courses start in the fall 2009 semester and then the spring 2010 semester are both. For this we can write the relational algebra. First we can call the projection operation, because we can select the course ID first. Okay, the course ID. Next we can call the sigma, that is a select the semester is equal to fall. Okay, next to put the intersection. Okay, so next year is equal to 2009 from the selection table. This selection is a table name. Okay, next again because we need to find the 2 year, that is the fall 2009 semester and then spring 2010 semester. Okay, so that again we have to write the course ID, the sigma semesters is equal to spring intersection year is equal to 2010, and then the section is your table name. So in this way it can be declared. And see the one more query. So that is the find the set of all the courses taught in the particular year. Okay, for this we can write the relational algebra as the course ID. So that is written by a pi, and then the semester is equal to fall, that is written by a sigma. Okay, and then the year is 2009 and the section is a table name. So this is our section table name. So section, so here are the section table name. Section is a relation, that is a table name. In that section table having course ID, section ID, semester, year, and then building, room number, time slot. These are the fields are there in that section table. Based on this section table, we can find out the following queries. Okay, so that is a course ID. The sigma semester is equal to fall, intersection year is equal to 2009, and then selection, here we are going to put the union operation here. Okay, and again we can call the projection for selecting the course ID, and then we can call the sigma for selecting the semester is equal to spring intersection year is equal to 2010, and then selection. So in this way it can be declared. Okay, this is a selection and then projection example. Okay, next. So the output will be like this. Okay, this is the output of this queries. Okay, and next let us see about set difference. Okay, so the set different, the result of the set different operation is a tuple which are the present the one relation but are not in a second relations. Here also we are going to take a two relation, that is R and S. Okay, so the result of the set different is the different operation in a different operation is a tuple which are present in a one relation but not in a second relation. Okay, so the set different, that is the result of the set difference operation is a tuple which are present in a one relation but not in a second relation. That is a written the relation instance containing all the tuples that occur in R but not in S. Okay, here also we are going to take a two relation, that is the R and S. Okay, so the R and S must be union compatible. Okay, which means that the result of the set different operation is a tuple which are present in a one relation but not in a second relations. Okay, so it can be written as R different, difference S. So this is the syntax of this set difference. So let's see the example. So here we are going to take a S1 table and then S2 table. Okay, then we can do the set difference. Okay, between these two. Okay, S1 and then S2. Okay, S1 table having a 3 rows. Okay, and then S2 table having a 4 rows. Okay, the operation is which are present in a one relation but not in a second relation. So that the output will be like this, because 22 that is presented in a S1, not presented in a S2. Okay, 31 also presented in a S2 table, and then 58 also presented in a S2 table. The 22 only not presented in a S2 table, so that the output will be like this. Okay, let's see the example of this set difference. So based on that is section relation table. Okay, that is a section relation table. Based on this, we can find out the set different example. Okay, that whereas we can find all the courses start in a fall 2009 semester but not in a spring 2010 semester by writing. Okay, first we can call the selection projection operations. By using this projection, we can find out the course ID. After that, we can call the selection operation, that is indicated by the sigma. By using this sigma, we can select the semester is equal to 4, intersection year is equal to 2009. Here we can put the intersection operations because we are using, that is the intersection. Okay, that is a set difference. Okay, so that we can put the, hyphen symbol here. Then again we can call the projection operation. By using this projection operation, we can call the course ID. Okay, next we can call the, selection operation, that is indicated by a sigma. By using this sigma, we can find out the semester is equal to spring, and then the sections equal, year is equal to 2010. Okay, so it can be, this is this output will be like this. Okay, so next let us see about the Cartesian product. So Cartesian product, that is indicated by a cross symbol. Okay, this is a cross symbol. Here also we are going to take a two relation, that is the R and S. So it can be written as R cross S. Okay, this is the syntax of this Cartesian product. Okay, this is used to combine the data from two different relations into one and fetch the data from the combined relations. Okay, when you are using a Cartesian product, this is used to combine the data from the two relations, okay, two different relations into one and fetch the data from combined relations. So the syntax is R cross S. Okay. For example, suppose there are two tables named student and then reserve. Okay. So in the two student table having a student ID as name and the student name and an age. And then the second table name is reserve. So in the table having a student ID, ISBN number and a day. Okay, like whereas find the name of all the student who have reserved ISBN is equal to 005. To satisfy this query, we need to extract the data from a two table. Hence, the Cartesian product operator is used as, okay, the sigma student.sid is equal to reserve.sid and put the intersection operation. Then again we can call the reserve.isbn is equal to 005 and then student into reserve, that is a student cross reserve. So student and then cross is a two table. Okay, so here also we are going to take a borrower and then loan, that is a two table. So for this we can find out the query, that is if we need all the borrower and then loan holder from a Chennai. Okay, for this we can write the relational algebra. Okay, that is a sigma branch is equal to Chennai and then borrower is a one table and then loan is another table. Okay, in this way it can be declared. Okay, so Cartesian product is the multiplications. Okay, the relations R and S. Okay, in a R table having a two rows and then S table having a four rows. So the Cartesian product means that is a matrix multiplications, that is a 2 into, so here the S table, R table having a two rows and then S table having a four rows. So 2 cross 4. Okay, we are getting 8 records. Okay, 2 cross 4. Okay, 2 and then cross 4. So 2 cross 4 is equal to 8. Okay, so that in a result matrix having a 8 rows. Okay, the output will be a 8 rows because we are using a Cartesian product, which means that there is a matrix multiplication. Okay, 2 cross 4 into 8. Suppose we are taking a 3 cross 3. We are getting the output as 9. Okay, suppose we are taking a 5 cross 5. We are getting the output as 25 records. Okay, so in this way it can be declared. Okay, when you are using a Cartesian product. Okay, next let us say about the gate question. The following questions has been asked in the previous gate exam. Okay, let's see that example. Okay, the first question, select the operation in SQL as equivalent to. Okay, the select operation here, they used the select operations. Okay, the selection operation as selection, the options A, that is selection operation in a relational algebra. Okay, Option B, the selection operation in a relational algebra, except that the select in a SQL's retains the duplicates. The option C, the projection operations in a relational algebra. The option D, the projection operation in a relational algebra, except that the select in a SQL retains the duplicates. Okay. So when you are using a select in a relational algebra, the option is A, that is the selection operation in a relational algebra, because they ask the select operations. Okay, in SQL the equivalent to means the selection operations in a relational algebra. The option C and D, that is given the projection operation, so that is a false. Okay. Then second question, that is let R is a relation. Okay, R be a relation instance with the schema R is equal to A comma B comma C comma D. Okay, we define R is equal to select A comma B comma C from R. So R is a relation. R is a one table. Okay, in the table having A comma B comma C comma D fields. Okay, the four fields are there in that R table. Okay, next we define the R1. So when you are define the R1, okay, we can select the A, B, C from a R table. Okay, so in R table having a B, C, D. Okay, so we can choose the three fields, that is A, B, and then C from a R. Okay, and when you are define the R2, okay, R2 is equal to select A only, A and D from a R. Okay, R1 select the A comma B comma C from a R, because the R table having a four fields, that is a B, C, D. R select the A comma B comma C from a R, and then R2 select A and then D from a R. Okay, let's S equal to R1 into R2. Okay, R table having a four fields. Okay, and then R1 table having a three fields. Okay, from R1. From R. Okay, and R2 having a two fields from R. Okay, let S is equal to R1 into R2, where the asterisks denote the natural join. Okay, given that the decompositions of the R into R1 and then R2 is a lossy. So decomposition of the R1 into R1 and then R2 is a lossy. Which of the following is true? Okay, S is a subset of the R, and then R union S is equal to R. R is a subset of the S, and then R asterisk S is equal to S. The options are S is a subset of the R, and then R union S is equal to R, and then R is a subset of the S, and then the option does R asterisk S is equal to S. The answer is C, because consider the following example with lossy. Okay, the decompositions of the R into R1 and then R2. We can see that the R is a subset of the S. So this is a table R. So in the table having a four fields, that is a B, C, D. Okay. So when you define the R1, select the A, B, C from the table R. Okay. When you define the R2, select the A and D from a table R. Okay. So let the S is equal to R1 into R2. Okay. Here we are using a natural join. Okay. That is R1 into R2. So that the result will be like this. Okay. So that the option is C. The C is R is a subset of the S. Okay. Next, let us see about the one more example, that is employee. So employee is a table name. In the table having a employee name, salary, department number, and another table name is department. Okay, the first table name is employee. In that table having a name, salary, and then department. Okay, another table name is department. So in the department having a department number, Okay. Employee. So employee table having a name, salary, department number, and then department having a department number, department name, and then address. Whereas, which of the following queries cannot be expressed using the basic relational algebra operations? Okay, when you are using a basic algebra, we should use, that is a selection, projection, Cartesian, and then union, intersection. These are the operators are we used. Okay, whenever using the relational algebra. Okay, the options, option A, the department address of every employee. So that is the relational algebra operations. Okay, and then option B, that is employee whose name is same as the department name. That is a main projection operations. Okay, and then the option C, that is the sum of all the employee salary. Here we don't use the sum operations. Okay, you should not use the sum. Okay, the first option, that is the department address of the every employee. Here we are using the selection operation, and then the option B, that is the employee whose name is same as that department name. Here we are using a projection operation because we are going to select only the employee, so names. Okay, and then the option D is all the employee of the given the department. Here also we are using this relational algebra. The option C, that is the sum of all the employee salary. This is not using in a relational algebra because that is a sum operations. Okay, so that operation is not using. So the 6 basic operations of the relational algebra are the selection, projection, Cartesian product, and also that is a set union, set difference, rename. So these 6 operators are fundamental in a sense that none of them can be omitted without losing the expressive power. Okay, many other operators have been defined in the terms of these. Among the most important are the set, intersection, divisions, and the natural joins. But the aggregations is not possible with basic relational algebra operations. So we cannot run the employees with 6 operations. So that the option is C. Okay, the option C is the sum of all the employee salary. This is not we cannot be expressed using the relational algebra operation. And then next question, that is, consider the following relational schema. Okay, consider the following relational schema, and then student, course, registration. Okay, the table name is student, and that the student table having a roll number. So roll number should be integer, and then yes name, that is the string. Okay, and the course table having a course number, that should be a integer, and then name should be a string. Okay, and then registration table having a roll number, that roll number should be a integer, and then course number should be a integer, and then the percent, that is a real. So real means that is a floating point. Okay, and the question is, which of the are equivalent to this query in English? The question is, that is the query is, which of the following queries are equivalent to this query in English? Okay, find the distinct student who scored the more than 90% in the course number 107. Okay, so here they use the 3 table, that is a student, course, registration. Okay, whereas the which of the following queries are equivalent to this query in English? Find the distinct name of all the student who score more than 90% in the course number 107. So the option is, that is, select a distinct S name from a student as S. That is the object of S is the object of the student, and then registration, that is define the R is the object of the registration, where the R dot roll number is equal to F dot the roll number, and here we are using AND operations. Okay, and then R dot course number is equal to 107 because we need that who score more than 90% in the course number 107. So that we are using here, that is AND operations here. Okay, next we told the R dot course number is equal to 107 and the R is equal to percent. We need a person also. Okay, that's a 90%. Okay, so that again we can call the AND operations here, and R dot percent greater than 90%. Okay, so and look at the second option, that is by using the projection operation. By using this projection, we can select the S name, and then by using the sigma, we can select the course number is equal to 107. So also true. Okay, so that the option is A, that is 1, 2, 3, 4. So these four options are true. So that the answer is okay. Next, let's see about the another example. That is consider the following two tables and four queries in SQL. Okay, so the first they given the book tables. Okay, the book table having a ISBN number and then book name, and then second table is stock. That the stock table having a ISBN number and then copies. Okay, so next the query 1. Select the B dot ISBN number. B is object of the book table. Okay, then it can be written as B dot ISBN. Okay, and then S is a stock object. Okay, so then it can be S dot copy from a book B, and here we are using the inner join. Okay, inner join. Then the stock of S, and then when you are using the inner join, the keyword is on. Okay, put in the inner join and then followed by the on. Okay, then B dot ISBN and is equal to S dot ISBN. Okay, when you are using an inner join, okay, return the record that is presented in the both tables. Okay, so next the query 2, select the B dot ISBN and S dot copies from B, and then here they use the left outer join. So return the left hand side record that is presented in a right hand side table. Okay, return the left hand side record that is presented in a right hand side table. Okay, and then query 3. So here they use the right outer join. So when you are using the right outer, return the right hand side record that is presented in a left hand side. When you are using the right outer, return the right hand side record that is presented in a left hand side table. Okay. In a query 4, they are using the full outer, which means that return the entire record. So that is presented in a both table and then B table. Okay, return the full record. So that the answer is query 4, because they use the full outer, then only return the entire record. Okay, so the option is D. In SQL, the full outer join combines the result of the both left and right outer joins and return all the rows from the table on both sides of the join classes. Okay, when you are using a full outer, return the entire record that is the tables both sides of the join class. Okay, so that the option is D. Okay, and then next question, that is given the relation R of W, X and then S of Y, Z. Result of select the distinct W, X from R and S is to be same as R provided. Okay, the given the relation R of W, X and S of Y, Z. The result of the select distinct W, X from R and S is guaranteed to be same as R provided. The options are R has no duplicate and S is non-empty. So R and S have a no duplicate, S has no duplicate and R is a non-empty. And then option D is R and S have the same number of the tuples. A. The query, select all the attributes of the R. Since we have a distinct in the query, the result can be equal to R only if the R doesn't have duplicate. Okay, the query select all the attributes of the R. Since we have a distinct query, the result can be equal to R only if the R doesn't have a duplicate. Okay, if we don't do any attributes on, we want to join two tables, then the query is like about become equivalent to the Cartesian product. Okay, when you are using a Cartesian product, for example, if you are taking a two tables, that is the first table having two rows and the second table having 5 rows, so that the 2 cross 5 are getting the 10 records. Okay, so the Cartesian product of the two sets will be empty if any of the two sets are empty. So the F should have at least one record to get all the rows of the R. So the option is A. The R has a no duplicate and S is a non-empty. Okay. So next, see the another example. The maximum number of the super key for the relation schema R. So R of E, F, G, H. With E as the key as the option A 5, and option B 6, and then option C 7, and then option D 8. The answer is D, because the maximum number of the possible key for the table with n attributes is equal to 2 power n minus 1. Okay, here n is equal to 4. So that the possible super key is equal to 24 minus 1. Okay, so the n is equal to 4 means the 2 power n minus 1, right? So that, so 2 power 4, so that is a 24. So 24 minus 1, so that is 8. The possible E, E H, E G, E F, E G H, E F H, E F G, E F G H. So that the answer is 8. Okay. Okay. Thank you. So any doubts so far? So in this section we discussed that is a relational algebra. So in that we have seen that as in selection operation, projection operation, set different, that is a set operation. So in that set operations having a union, intersection, Cartesian product, right? And then we can see the join. So if you are using a join it together by using a common attributes. Okay. So it's in normal join. Okay. So return the record that is presented in both tables. So using left outer, return the left hand side record that is presented in a right hand side table. So using a right outer, return the record that is presented in a left hand side table. So using a full outer, return the entire record that is in both tables. Okay. Any doubts so far?